And Nmap scan can produce a screen full of ports in seconds. But the useful skill is not typing a command. It is knowing what the result means, what it does not mean, and what to verify next. Think of a port scan as checking the numbered doors in an office hallway. A door that answers tells you something may be listening behind it. It does not prove who is inside, whether the room is secure, or whether you are allowed to enter. Nmap helps you map the doors. Your job is to interpret the signals responsibly. In this original CipherVibe guide, we will move from a first scan to a defensible finding inside an isolated lab. We will discover an owned target, scan a small set of ports, identify a service, compare the result with evidence on the target, make one safe correction, and rescan. Use Nmap only on systems and networks you own or have explicit written permission to assess. Scanning can trigger alerts, consume resources, and violate policies. Our example uses a fictional host-only lab address and no live public target. Nmap is an open-source network exploration and security auditing tool. At a high level, it sends carefully selected network probes and classifies what comes back, or what does not. There are 3 beginner questions. First, is the target reachable from this location? Second, which network ports appear reachable? Third, what service may be responding on an open port? These are observations from one scanner at one time across one network path. A firewall, access control list, host state, rate limit, network translation, or temporary outage can change the result. A scan from inside the lab may differ from a scan at the lab boundary. That is why scope comes before syntax. Write down the authorized target, allowed time window, source machine, permitted scan intensity, contacts, and stop conditions. Begin with the smallest question and the least traffic needed to answer it. Nmap is not automatically a vulnerability scanner. It can help inventory exposure and identify likely services. A version string may guide further review, but it is not proof that a vulnerability exists or that an exploit would work. Our practical example has 2 virtual machines on a host-only network. The analyst machine uses the fictional address 192.168.56.10. The Ubuntu practice server uses .20. Both belong to the learner. The segment is not routed to the internet. On the target, we intentionally enable Secure Shell on port 22 and a small web server on port 80. We also start a temporary development service on port 8000, so there is one unexpected item to investigate. Before scanning, confirm the target address on the target itself. Record the expected services and take a clean snapshot. On the analyst machine, check that Nmap is installed from the operating system's trusted package source, then read its built-in help. Exact installation steps and privileges vary by platform, so follow current official documentation. Do not copy a random internet address into a tutorial command. Private address space is not automatically yours, and a virtual machine can accidentally be bridged to a real network. Verify the adapter mode, ownership, and authorization before sending the first probe. For an owned lab inventory, a host discovery pass can answer which addresses appear active without performing a port scan. The command is nmap space -sn space 192.168.56.0/24. The -sn option asks Nmap to perform host discovery and skip the port scan. On a local Ethernet segment, Nmap may use address resolution behavior in addition to other probes. The output should show our 2 lab machines. Treat the list as observed, not complete. A host can be offline, block a probe, sit behind another path, or appear under a different address. Compare the result with the hypervisor inventory and your lab notes. If the target is known and authorized, but discovery does not find it, troubleshoot the virtual adapters, subnet masks, routes, and firewalls before adding more aggressive options. Do not treat silence as evidence that no device exists. For a single known target, you can skip the subnet sweep and scan only that address. Narrow scope reduces noise and makes the result easier to explain. Now scan only the ports relevant to our lab question, 22, 80, for 43 and 8000. The command is nmap space -p space 22, 80, 443, 8000 space 192.168.56.20. An open state means an application on the target is accepting a connection, packet, or datagram for that port. Closed usually means the host is reachable but no application is listening there. Filtered means Nmap cannot determine whether the port is open because packet filtering prevents a decisive response. Nmap can also report combined states such as open or filtered when the evidence cannot separate them. That uncertainty is useful. Do not rewrite filtered as secure, and do not rewrite open as vulnerable. In our example, 22, 80, and 8000 are open. For 43 is closed. The interesting finding is not that open ports exist. It is that port 8000 is outside the expected service list. Save the output with the date, scanner location, exact target, and command. Findings without context age badly. Next, use service and version detection only on the 3 open ports, Nmap, space, -SV, space, -P, space, 22, 80, 8000, space, 192.168.56.20. With -SV, Nmap sends service probes and compares responses with its fingerprint database. It may identify a protocol, product, version, device type, or operating system family. Detection can be incomplete or wrong. Services can run on unusual ports, hide details, sit behind proxies, or return custom banners. Suppose Nmap labels port 8000 as an HTTP development server. That is a useful hypothesis. On the Ubuntu target, an authorized administrator now checks listening sockets with the local operating system tools, reviews the service manager, and examines the process owner and configuration. The server log confirms a temporary development process bound to every lab interface. The defensible finding is, an unapproved development web service was reachable from the analyst segment on TCP port 8000 at the recorded time. The Nmap fingerprint helped locate it. The target-side evidence confirmed it. We still have not claimed a vulnerability or attempted exploitation. Different questions need different approaches. Use host discovery when the goal is an authorized asset inventory. Use a focused port list when validating a firewall change or known service. Use service detection when a reachable port needs identification. Use repeatable output when comparing a baseline before and after a change. A default Nmap scan examines the most commonly used 1000 TCP ports, not every possible TCP port and not all UDP services. A narrow scan is clearer for a first investigation. A broader scan may be justified during a formally scoped assessment, but it creates more traffic, takes longer, and may affect fragile devices. UDP scanning behaves differently from TCP and can be slow or ambiguous because silence may mean open or filtered. Operating system detection and the Nmap scripting engine can add information, but they also add probes, dependencies, and risk. They are not required for this beginner workflow. Do not paste an all-in-one aggressive command from a cheat sheet. Every option should answer a documented question. If you cannot explain why an option is present, remove it and consult the official reference guide. The system owner confirms the development server is no longer needed. They stop and disable that service, remove the temporary configuration, and confirm port 8000 is no longer listening locally. If the service were required, the safer response might be binding it only to localhost, restricting it with a firewall, adding authentication, or moving it behind an approved gateway. Now rerun the same focused Nmap command from the same analyst machine. Port 8000 should be closed or filtered according to the chosen control. Ports 22 and 80 remain expected. Save the before and after outputs and link them to the change record. Common mistakes include scanning the wrong subnet, trusting a service label without validation, treating closed as permanently closed, assuming filtered means safe, scanning too broadly, omitting timestamps, and declaring every open port a vulnerability. If a scan causes latency, service instability, or an alert outside the agreed window, stop and follow the engagement plan. Production and operational technology networks may require special approval, passive discovery, vendor guidance, and much lower impact methods. Nmap becomes valuable when it supports a disciplined workflow. Start with written authorization and a narrow question. Discover only the owned systems in scope. Scan the smallest relevant port set. Read states as evidence from one path and one moment. Use service detection to form a hypothesis. Validate important results on the target or with another trusted source. Remediate through the system owner, then repeat the same scan to verify the outcome. Remember the hallway analogy. Nmap which numbered doors respond. It does not tell you the full story behind each door, and it never gives you permission to enter. Your practical next step is simple. Build a 2-machine host-only lab, enable one expected service, record a focused baseline, make one authorized configuration change, and compare the result. Keep the command, timestamp, scope, evidence, and conclusion together. This is original CipherVibe educational content. Use Nmap only on systems and networks you own or are explicitly authorized to test. Copyright 2026 CipherVibe. All rights reserved.